Part 3, operation with fractions. So we have three properties here. They don't look very intuitive for the first look, but we can we'll use the first one as an example to prove this is right. So if we go from the right-hand side of this first property, n, 1 over n, 1 over n plus 1, these two has two different bases. If we want to put them together, for example, I can multiply n plus 1 to the first number, top and bottom. I can multiply n to the second number, top and bottom, to make them the same base. So now my bottom is n plus 1, multiplying together. They both have this, so I collect the two terms. And the first term would be multiply top bottom n plus 1 minus the second term would be multiply top and bottom by n. So now n minus n, these two cancel. So the top would be 1. The bottom is n plus 1. So this is how we prove this equals to this. And for the next two properties, we want the students to kind of practice. Just by default, you can just start from this, right? These two are the same. So basically, the sum of this is 1 over 2 and multiply 2. So that goes to this. And similar for this problem, for this property. Practice problem 16. So we have a sequence, sum of the sequence. So we look at the pattern. It's very similar to this one with k equals to 2. So if n is 1, so 1 multiply 1 plus 2 plus and so on. So applying this to the first term is, since k equal to 2, this first term is 1 over 2, n is 1. That's 1 minus 1 plus 2, 1/3. And this second term is still k equals to 2, but n now equals to 3, right? This is n plus k, minus n plus k, that's 5, plus the next term we can kind of figure this out, must be 1, 3, 5, minus 1 over 7, and so on. 1/2 in the beginning can be taken out. Then we have 1/2 of 1 minus 1/3 plus 1/3 minus 1/5. You can see this two cancel. Add the next one, 1/5 minus 1/7. These two cancel. So you can kind of imagine that the middle term all cancel. What you're left with is the last one. So the last one would be minus 1 over 101. So that's what's left over. So eventually you would have 1/2 first term minus all the middle terms cancel out, 1 over 1. So the students can carry this one out. Practice problem 17. Container is 3/5 full of water. If 16 gallons of the water were removed from the container, it would be 1/3 full. How many gallons of water does the container hold? So last year we have introduced the idea of drawing diagrams. So if we separate this thing into 5 equal parts, almost equal. So 3/5 is full of water. If 16 gallons of the water were removed from the container, then it would be 1/3 full. 1/3. 1/3 is somewhere around here, okay? So this part is removed. That's 16 gallons. 16 gallons equals to what? Fraction-wise. Fraction-wise is 3/5 minus 1/3. So 16 gallons equals to this fraction. So we basically have 16 over 3/5 minus 1/3 would give you the total. Practice problem 18. So which one, if this equation, if the right-hand side is greater than the left-hand side, what is the x that could not be which of the following? That means x cannot be any of the numbers that to reverse this inequality. So right-hand side and left-hand side, there's a common of 1/8. We can get rid of that. 1/2 plus 5/5 greater than 1x plus 1/6. Okay, we can subtract 1/6 from both sides. Then this one becomes 1/3 plus 1/5 greater than 1/x. So this would be 15/8, because we multiply 5 on each side of 1/3, multiply 3 on each side, so add them together. This would be 1/x. The students can try these out, which one cannot be used to reverse this inequality. 19. Which of the following numbers is between 1/6 and 1/5? So we have to carry this out, 1/6 in decimal and 1/5 in decimal as well. 1/5 in decimal is just 0.2. So carry out 1/6 in decimal, then you will find what's the range between these two numbers and find out which is the right answer. Practice problem 20. On each of the days, Monday through Thursday, Tony spent 2 hours commuting to work, 1 hour back. What fraction of the total number of hours in these 4 days did she spend commuting? So the percentage or the fraction on each day is the same for all 4 days, because all 4 days are the same. So for each day, she spent 3 hours on commuting to work and back, right? 2 go and 1 back. So total 3 hours. Every day there was 24 hours. So the fraction is 1/8. You can count all 4 days, then you basically multiplying 4 to both top and bottom. That doesn't affect the answer of the fraction. So the answer is 1/8.